Good day, learners. I'm pleased to send you another video on the law of counting, permutation and combination. It's going to be very brief, but after the video you will just go and study this book so that you can get the full understanding and practice all the examples in the book. Now, first law of counting: if an event A1 can occur in N1 ways, therefore an event A2 can occur in N2 ways, both A1 and A2 can occur in N1 times N2 ways. For example, if you roll a die once, then you toss a coin. You have two events: rolling a die and tossing a coin. How many ways? How many outcomes can you get? How many ways can they come up? So the possible outcomes is going to be, so how many outcomes can you get when you roll a die? You can get 6. And then how many outcomes can you get when you toss a die? Is 2. So both from the law of counting, you can get 6 times 2. Now which is 12 outcomes for the two events. Let's go to the second law quickly. The second law of counting says, if an event A1 can occur in N1 different ways and an event A2 can occur in N2 ways, then either A1 or A2 can occur in N1 plus N2 different ways. So using our example, let's toss a die and a coin, and you roll a coin once. So let A1 be the event. So the tossing of the die show an even number, and A2 be the event. The coin lands head. So A1 can occur in 3 ways for a die, which is 2, 4 or 6, and A2 can occur only once. So the number of which an even number or a head be obtained is 3 plus 1, which is 4. So I want you to look at this sample, study it, and write it down yourself. Now I'm taking you now to what I call permutation. So that's the next thing we are going. Permutation and combination. That's this topic. Now, under this topic, we are going to differentiate between permutation and combination, and we are going to see how they got the formula for permutation and combination. So first I start. A permutation is an arrangement. I want to underline the word arrangement there. Arrangement of objects in a definite order, called order sample. While a combination is a selection of objects without regard to order. So I want to underline selection. So permutation has to do with arrangement, while combination has to do with selection. So let's now go to permutation. Supposing you have a group of letters A, B, C, D. In how many ways can they be arranged? So number 1, you can have A, B, C, D, B, C, D, A, C, A, D, B. You can see there are different arrangements. Do you understand? You can see there are different arrangements. So how many ways can they be arranged? You can see, to get how many ways they can be arranged, you can see that this letter A, it can take 4 different positions. So letter B, after letter A have taken its position, letter B can take 3 different positions. Letter C can take 2 different positions. Letter D can take 1 different position. So from your law of counting, so the possible number of ways is 4 times 3 times 2 times 1, which is the same thing. 4 times 3 times 2 times 1, which is 24 ways they can be arranged. 24 permutation of the 4 letters, and it's written like this. So how many ways can a 4 letter be permutated? 4 letters out of 4 be permutated. So it's going to be 24 with 4 times 3 times 2 times 1. Now I want to take note of this notation. When you have this notation, is called 4. This is 4 factorial, and it's denoted by this. So when you have I'm looking at, there is a way they normally write it, 4 factorial. So now permutation of n distinct objects. Consider a set consisting of n distinct objects. Permutation of this set consists of an n effect. So, and there are n multiplied by n minus 1 multiplied by n minus 2 times 3 times 2 times 1 permutation of n object, which is called n factorial. This is the way they write it, n factorial. Now let's look at this example. Supposing you are not permutating all the n objects. Supposing you are permutating r out of the n, that is among some certain number of the object among the n. So for example, if n balls are distributed at random into r buses, how many ways can this be done? So now solution, let a1 different position, I mean the different boxes. So to find out how many ways they can be distributed, so it's going to be r multiplied by r1 multiplied by r2 up multiplied by r minus n plus 1. You can try. This is the formula now for permutation. When you are now taking when you are not permuting all the objects, when you are taking maybe certain number of the objects and you are arranging it. So this is the formula: r multiplied by r minus 1 multiplied by r minus 2 multiplied by r minus n plus 1, where n must be less or equal to r. Okay, please take note of that formula. Now let's look at an example now. Let's assume how many permutations of 3 letters can be formed from letter A, B, C, D. No, you have 5 letters now, which is our n, and you want to arrange 3 letters out of it. So since the permutation consists of 3 letters, 3 effects are involved. A1. So there's going to be 5 multiplied by 4. This is 60. So there are 60 ways. So, and it's denoted that by permutation of 3 letters out of 5. Permutation of 3 letters out of 5. Let's now derive the formula. So now from this definition, this is how you normally write permutation. N permutation r. So it's given by this formula, which is derived from here. Now, as you can see from this formula, we notice that this is the formula for permutation, but n factorial is this. So now from here, if you look at this formula from here, n minus r multiplied by n minus r up to 1 is the same thing as n minus r factorial. So therefore, if you now make this place now, this is the permutation. So this is the permutation. This one is n minus r factorial. So which means our permutation is n factorial divided by n minus r factorial. So that's how we got the formula for permutation. Anytime you are asked to do a permutation of r object out of n object, so the formula is n factorial divided by n minus r factorial. So I want you to look at this example. I want you to study it. Of course, I'm going to give you an assignment now that will make you study this example. Now quickly, I want us to look at combination. Combination is different from permutation, because in combination we are now selecting. You have a group of letters and you want to select out of it. So the formula for combination is, I want to read this. The formula for combination is number of permutation divided by the number of objects, the factorial of the number of objects. So commutation is given by n. This is the permutation, n factorial divided by n minus r factorial, r factorial. So this is where we stop. So please, I want to take note of this, read it, study it, and then we'll do assignment later.